Oh, what's up, Alexis? All right, let's do this. All right, so we got two problems. We got x times x cubed. Let's just do this online real quick here. Okay, so we got x times x to the power of 3. I'm just doing it in here to get a good... It looks good. I'll do that. I'll do that. All right. Okay, now, the idea with these exponent rules, right? This is called the product rule. This is when you have two bases that are multiplied together to the same base with different exponents, right? So the exponent that we have here is a 3 and actually a 1 right there. And actually, I want to make that bigger. So yeah, you have a 1 here and a 3 here, right? So the idea is you're going to keep the base the same. Again, the exponent is the base, but you can also have something like this, 2 cubed, where this would be the base and this would be the exponent here, right? Okay, so the idea is that you're going to basically keep the base the same and add the exponents. So we can show this in a couple different ways. You could show this as x to the power of 1 plus 3. Gosh, this is awkward. I wish I had like a stylus or something. That gives us x to the power of 4. Right? You could also kind of spread it out and be like, all right, well, I have an x here, and that x is represented. That's that x right there. Okay, and then the other x's, right? These here would be represented just by kind of spreading out and writing 3x's, right? Kind of expanding it out. And then when you count them, you've got 1, 2, 3, 4. So you've got that x to the power of 4. That's the idea here. Yeah, that's that. So that would be x times x cubed would be x to the power of 4. And then let's see our next example. I think it was like really similar to that. No, that one. X to the 6th times x to the 5th. Okay, cool. So this is x to the 6th, and then x to the 5th. Okay, we'll just screenshot that again and do the exact same thing. But I mean, it's the exact same thing, just different numbers, right? So what we could do, right, is we could write out 6 x's, and we could write out 6 x's and then 5 x's, and then count them out to get to 11. Or we could just show it like I've got x to the power of 6 plus 5, and that equals x to the power of 11. Okay, so that's your shortcut right there. I mean, again, you could write out 6 x's and then 5 x's and count them up, but you'd get to 11. So it's kind of the same way. You might be thinking, like, when I multiply these x's, why isn't this 6x versus x to the 6th, right? And the reason is, let me just get rid of all that. It's the difference between addition and multiplication, right? So if I have like x squared is the same thing as x times x, right? But x plus x is 2x, right? So two different operations. We are not working with addition here. We are working with multiplication, right? So don't get confused and say, oh, like that x squared would be 2x, right? Just don't get them mixed up. You just got to make sure you recognize these situations when it is multiplication. Yeah, I mean, this is exactly what we're going over in 8th grade right now. You'll see other types of problems. You'll see maybe, I'm assuming that she shows multiple kinds of problems. I guess I'm assuming your math teacher's a woman. I don't know. You might see something like this, where it's like, I don't know, let's say 5 to the power of 15, and then 5, make an exponent, 5 to the power of 8, right? If you see something like this, right, it's it's really similar. It's just inverses or opposites. So rather than multiplication, it's division. And where did I go here? I want to do this, right? It's, oh man, that was way, I shouldn't have done 15. I should have done like 6 and 4. Yeah, there we go. Because I don't want to have to write that many. Okay. Okay, so the idea here is you're going to have 6 fives on top. So you'd be like 5 times 5 times 5 times 5 times 5 times 5 on top, right? And so this is division instead of multiplication. So the idea is you're going to subtract your exponents, right? And you'll see kind of what this looks like. And on the bottom, I'm going to have 4 fives, 3, 4, okay? And what you'll notice as we do this is that 5 divided by 5 is 1. So when you multiply by 1, you don't change it. So you can actually kind of just cross them out like that, and you're left with 2 fives. But again, this isn't 2 fives, it's 5 squared, right? So it's the same thing as the previous problems that you showed me in your email, just the inverse of the opposite. So hope that helps, dude. If not, let me know.